Hey, hello everybody. Good evening. Hope everyone's doing all right. Really good activity on Piazza, by the way. Special shout out to Baby Doll. I think a lot of you um, have been helped by Baby Doll, who's been very, very active on the Piazza discussion. So shout out for that. That's awesome. But all of you for asking questions and answering questions and giving feedback. That's great. Hopefully we can keep that going and make some use out of that tool other than and make it more than just busy work. Okay, so yeah, the Baby Doll's really contributing a lot. Everyone else should try it. It takes a little bit of courage to go out there and offer an answer, and you may or may not be 1,000% certain all the time. You watch me make mistakes, so there's never any harm in it. I think everyone just respects the fact that someone steps in and tries to help. Although Baby Doll's help has been really terrific, so she's set the bar quite high for everybody. Okay, we're in week 5, so we are making good progress through the semester. I'll just point out to you here on the home page in Canvas that the individual project is due in just under 2 weeks now, so about 12 days. At this point, you actually have all the information that you need to complete it. Now everyone's had a programming class, so there shouldn't be any surprises in terms of the algorithms. It's just a matter of getting comfortable, if you need to, with the C++ syntax, making some choices about how you're going to theme your project, if you're going to do something that feels more like a vending machine or feels more like a convenience store. That's totally up to you. You sort of make whatever choices you would like that make it most interesting or challenging for you, whatever it is that makes you want to sit down and work through it the most. What else about the individual project one? That's it. There are some choices you have to make about how to organize the code. You are required to use a struct or a class. So that's sort of one of the big constraints on you, is that you have to do something that organizes your code around a struct or a class. And if you don't have any ideas yet about how to do that, then get on Piazza and discuss it, because there's a lot of people giving good feedback there. The other thing I want to do before we get into this week's content is click on the first team project and talk about it a little bit so that you know what's coming. It's not very big, but you don't want to let it sit there until the last second. So I'm going to click on it and talk a little bit about what's going on with the team project. So I will tell you that my view in Canvas does not allow me to show the same view that you see as a student in Canvas, and particularly when it comes to group assignments or team assignments. I don't have any way of seeing Canvas in the same way that you do. So the best I can do is describe for you what to expect and then show you where I've tried to add some additional help. So you should, in Canvas, on the left bar here, see a groups link. And if you click on your groups link, you should see a Team Project 1 group for you in there. If you go to your Team Project 1 group, you'll find that your group has its own page that your group owns inside of Canvas. So you have discussion boards, you can create content in there. So if nothing else, you can start using the groups to figure out who's on your team and to start messaging each other a little bit and discuss how you're going to attack the project. It's not a very big project. It's got one algorithm that I consider to be somewhat challenging, so you might want to work together on, and I've labeled it in the code, like this is the most challenging algorithm I think I wrote in there. So anyway, you want to start making contact with your group. If you want to move your group's discussions onto Piazza, you're welcome to do that. Your main challenge really on this first team project is to just figure out how you're going to make this small programming challenge work in your group. There is down here in the description section, if you've never done a group project in Piazza, I've added a link to a video overview. So this link here is a video overview that shows you what it looks like for a student in Canvas in a group project. So if you've never done a group project, please watch this video. It will tell you how it works, where to find information about your group, hopefully all of the basics that you need to get started. That's a good question. So the question is, will the groups be the same for the second team project? And I wasn't planning on doing that, but I might ask people inside of Piazza at some point after the first project's done what people thought, if they want to keep the same team or switch. Hold on, let me block a thing. Okay. So my plan is to make new groups for the second team project, but I'm open to keeping the same ones if people think they would like to do that. Anyway, so the instructions are here. They look like a normal project. They're less points, so your individual projects are 500 points, and this is 250 points. And your challenge really is just to get the thing to work. That's mostly it. Mostly it. I'll answer questions as much as I can, but really what I would like to see happen is that you take this opportunity to sort of figure out how to create a workflow with a team of classmates. It's a relatively small project again, so hopefully you won't find that you need tons of time for it. It's mostly about figuring out how to communicate with each other. So that's the team project. But sooner than later, have a look and see what's in there. I'll click on the link and just show you what it looks like in GitHub. So it looks like a lot of stuff, but none of these is very large. So the idea is that one or two people take on each component and work on that. So some of you have 4-member teams, some of you have 5-member teams, just because there's an odd number of people. But if you have any struggles with the teammate or anything, of course, just please let me know. That is due on October 18th. So that's about a month from now that's due. That's a good question. So yes, when you turn in the team project, I think that it's just one person turns it in. Yeah, that's how I understood the setting that I had to make on it, is that your team choose one of your members to make the submission for the whole team. Yeah. Okay, so that's team project 1. Sooner than later is a good time to go look so that you know what to expect and maybe get some communications going with your team members. Again, it's not very big, so it's not really designed to be a big project blowout. It's designed to give you that experience of working in a group. Okay, so we are in week 5. And like I always do, I'm just going to step through the week's pages and just to see what we can expect. Now, obviously, I know what the lab is, but I'll step through here just to remind you that all this content, or at least these sort of reminders, are here. Okay, so the big new thing this week is that we're going to do fully object-oriented C++, and we're going to do it by separating the declarations of things from the definitions of things. So we're going to do sort of like a full-on, even though miniature, a full-on object-oriented C++ program. I've created a class, and I don't mean a class that you go to school for, but what we call a class, very much like a struct. I've created the declarations for you in what we call a header file, and then I have given you a blank implementation file where you'll put the definitions. And I'm going to do examples so you'll see what it means to work in separate files. So that's the big new thing, is a new way of organizing the code in C++. We're going to do the O-string stream thing again. So just like last week, we're going to take the information about an object and we're going to put it into a formatted string. That way we can write unit tests for it, and I just think it's a good programming technique. So it is meant to be very similar to what you did last week so that you can get accustomed to doing it. And then, like we'll be doing pretty much for the rest of the semester, there's a unit test that will apply. Okay, so we're going to create a C++ class. We're going to implement it in 2 separate files. And then we'll make and then we'll use a unit test to see if everything is correct. So we're in chapter 7 of the Xi book, Objects and Classes. I'll come back to this page after I go through the other pages. So you'll get used to this routine. Most weeks are like this. You'll get a link to a repository that has 1 or more files in it and make a REPL and so on. The Piazza discussion, some of you have already been doing this, which is awesome. So sometimes I'm going to use the Piazza discussions just to sort of ask you to go out and do some bonus learning, as it were. But the reason why we're doing this in part is because we're doing object-oriented programming. Kind of for the first time, formal object-oriented programming in C++. And some of these people are very, very important in terms of just programming period or specifically object-oriented programming. And some of you have already picked a person and looked them up. I've actually been to Grace Hopper's grave. She's buried at Arlington National Cemetery in Washington, D.C. So that's just a little bit of Wikipedia reading to do. A little bit of history, which just to know sort of who came before us and how we got to this point. And then the reminders. So the week 5 stuff, the individual project that's coming due in just under 2 weeks, and then team project 1 is coming due in just under a month. So I know it's a little bit of juggling, but what I recommend on the first team project is you start making contact with your teammates and get a handle on what that project's going to require of you. Okay, back to the lab. So I'm going to pop these things open just to have them when I want them. So the Lab 5 repository and the doc test library. And I'll come back to that after I've implemented some code. So now into REPL. Hopefully I'm not flipping the tabs too fast. So I have the lab assignment, and then I clicked on the Lab 5 repo link, and I clicked on the doc test link, which opened up this doc test tab and this Lab 5 repo tab. It's got 3 files in it, so your REPL is going to have 4 things, because these 3 plus doc test. And then I opened up Replit so I can start doing a little bit of programming. Okay, so I'm going to create a new REPL for Lab 5. So I appreciate that what's going to happen, until you get used to it, it's just going to feel weird that things seem like they're all over the place. Like, why do we have all these separate files? The truth is, we don't actually have to have everything in separate files. In C++, you can write every bit of code that you need for giant applications all inside of one file. The reason why we don't do that, though, is because if we separate out the separate components into their own files, it makes it a lot easier to lift those components and reuse them in another application without having to hunt down things in big chunks of code and copy and paste them. So this makes the code a lot more reusable if we do it this way. And it makes it a lot easier for us to share the components that we create if we do it with separate files. But I realize that at first it's gonna feel weird if you haven't done this kind of programming much. That there's stuff just all over the place. So we'll just do our best to be careful about it. I'm going to start by doing everything in one place and then show you kind of how the pieces get moved for organizational purposes. So I'm going to create a class. And I'm always thinking about food at this time of day, so I'm going to try to not program food. So let's just do like a movie. Let's call it a movie. Maybe we'll sort of think in terms of Netflix. So just like we did with a struct, you're going to notice a lot of similarities here. But you're also going to notice that I write the code slightly differently because the way that we tend to code classes in C++ is different than the way we tend to code structs, even though they're very, very similar in terms of what they will allow. So here's a class. They always end with this semicolon. It's a requirement in C++ syntax for creating a class that you do that. Later in the semester, we'll actually take advantage of this semicolon to do a little trick. But let's make a movie. So one thing you're going to immediately notice is that I section off the code, the parts of the movie, into public and private sections. So you can do this in a struct, but it's not the sort of traditional way of programming a struct in C++, but this is the traditional way of doing a class in C++. So the things that go in the public section are things that can be used outside of this block of code. If it's in the private section, then it can only be referred to inside of the movie class. I'll do a quick example just so you can see that. So let me add a string here. I'm also going to do the standard namespace directives so that we don't have to do the std::: stuff. In fact, I don't need that line anymore. Okay, so I added string, I added the using directive, and then I have this class that I've spun up. Now notice it's completely separate from main, and that's quite on purpose. So let's give the movie a name. And then we'll create a movie object. I don't know if old movies, I don't really have any recent movies in my mind to work with, but one-word movies if you're in chat, so that it's I don't have to type as much. So I'm going to run this. I'm going to get an error. Okay, so you see immediately name is a private member of movie. So this kind of thing is confusing at first, but you sort of have to think of movie as being its own unit of code. It has an opening curly brace, it has a closing curly brace. So anything that's in the private section is limited to the scope of the movie itself, which means that once I leave that scope, like down here in main, I can make a movie, but I can't access the name like this because the name is private to the movie class scope. That's very different from structs. Typically, with a struct, we don't use the public and private modifiers. We just say struct movie and then the program is perfectly happy to run with it at that point. So just note that difference. At some point you're going to say, then why do we cause ourselves? Because making things private creates extra work. And there's going to be times when you're learning to do object-oriented programming where you're going to say to yourself, why are we doing the extra work? Mostly at this stage, we're doing the extra work to get you in good habits of C++ object-oriented programming. So once you've developed sort of good traditional habits of object-oriented programming in C++, then you can start making your own decisions about when you want to sort of bend or break the rules a little bit. Obviously, you can't break the rules of the language, but you can break the rules of traditional practice. So for now, let's learn the traditional practice, and then you can decide at stages when you think you might want to break the rules. So the fact that this name is private causes all kinds of problems. I can no longer just directly access it and change its value. So what happens when you make private things is that you have to make public things to allow access to the private things that you want to allow access to. So as it is right now, movies have a name, but the program can't access them. So what we would typically do is we would write what we call setters and getters. Some of you may have heard this before. So we actually write functions in the public section that allow access outside of the movie class to this data. Let's just put it in here for now. You're going to see me do something weird here. Okay, so because this function is public, I can now invoke that function from outside the class because it's public. You're going to see a handful of new things here, so hopefully if you need to, you can go back and sort of stop, rewind the video later. But you're going to see me do, this is called the this pointer. Some of you have worked in languages where you've seen the keyword self. This is C++'s self. It's a self-reference, and that also is something that's just going to be weird. But let me just show you the problem if I take the this off. So if I take the this off, C++ doesn't know which name is which. So you notice there's like name, name, name all over the place. Which one is which? So what this does, and I mean literally what this does, is it allows C++ to figure out which is which. So when you say this something, you're referring to one of the declared members of the class. So when it says this name, C++ has to start looking around in here and see if it could find something called that. And here it is. So that's what this does. It's not the most elegant setup, but C++ has a lot of weird stuff like this. Now C++ knows, okay, so this one without anything else on it means the parameter. So the parameter comes in, we take it, and we assign it to the name that's inside of this movie. This is how I speak it to myself. Pretty weird, huh? Okay, but now that I have this public thing, I can set the name, and then you'll often write alongside it, write a getter that returns the movie's name. Again, this is sort of just a heads up, right? I wrote all that code simply because I put this string inside of the private section, and that's totally true. That's why those things are there, is because I made this private. Now, the reason I did that is because it's sort of the standard accepted traditional practice, is to hide your data behind this private section and then expose your data through functions in the public section. I'll show you an example here in a second of how we can use that. So now I can say, so now I use the get name when I want to print the movie's name. And I'll run that just to show that JAWS appears. Alright, so there's the JAWS. Alright, so not the most exciting code, but we're setting up to do bigger and better things with C++ classes. So I'll read this movie class to you as I would read it to myself with terminology. So let me put a note in here. So I hope that the commenty ones, that gray commenting, might be hard to read. So we often in object-oriented programming create what we call setter functions. The fancy word for that is a mutator. And they're functions that allow us to mutate or set the values of private data members. That's typically how they're used. This function is called a getter, aka an accessor function. So most programmers will just say you're going to need a setter and a getter. The textbooks might say mutator and accessor. That's the fancy words for that. So setters allow you to change data members, and getters allow you to retrieve the values of data members. Now I'm saying data members, so now I'll go back a step. So in this class movie, I see two public members. I see a member function called setName, and I see a member function called getName. So those are both public member functions. Now I also see a private data member, which is simply just a declared variable, right? A private data member. But knowing that about a movie means that if I create a movie, like M1 here, I can use the two public functions, and I understand that inside of it is being stored a private piece of data. Turns out in this case that the two public functions allow me to alter and retrieve the value of the private data member. Fancy words. So movies have a setter for their name, they have a getter for their name, and they have a name. That's sort of more common language. So if I create another one, I'm going to take out some of the blank lines to not get the screen too stretched out. So because M2 is a movie, I know it has two public member functions. It has a setName member function, something short. What's a short movie name? I haven't seen that, but that's a movie that's out there. And they're not paying me for the product placement. Oh, Cars! Okay, I'll keep Cars. I'll keep Cars for the next time I need one. Okay, so every movie has a string name, private data member, and every movie has public setter and public getter for the name. So typically the setters, that's what they're for, is to allow you to change the value of that underlying private data member, and then getters allow you to retrieve the current value of that data member. So there's sort of a quick starter on class movie. So before this gets too big, we're going to start separating out into pieces. Now I'm going to have to retype some of my codes because I think that's probably the easiest way for you to keep track of what I'm doing. But usually what we do, sort of in the real world, you'll see me break this rule occasionally during the semester, but usually when we have the initial class declaration, class movie, and we announce the public and private members. Oh, Jumanji's another one too. Okay, that's a good one. So usually what we do is we use the initial class declaration only to declare things. So notice what I've done to set name here. I took the block out and I put a semicolon at the end. So what this becomes now is a declaration of a function. If you're coming from the Go language, we don't do that in Go. If you need a function, you just write the function. But in C++, you can declare a function in advance of actually defining the function. So I'm going to change the movie class, and I'm only going to have inside of the class the declarations of things. So here's the declaration of the setter, the declaration of the getter, and still the declaration of the private data member. Oh, frozen's a good word one too. Okay, so then the question becomes, well, where do the definitions go? And this part doesn't look pretty. C++ does not do this pretty. But it's very common practice to just declare things inside of the initial class declaration and then separate out the functions. So their actual definition. So there's the two definitions. They're not correct yet, so don't press run. But I just wanted you to see before I get too much further what I've done here. So I have the class that now only contains declarations of functions and data. I have the two functions defined outside of the class, which is actually wrong. There's a problem with this, but it's a start. Okay, so this is actually a fairly content-dense lecture, so apologies for that. Hopefully everyone's more or less following along what I've done so far. So the class, only declarations. I took the definitions of the two functions. So notice that now the semicolons went away. The declarations just end in a semicolon. The definitions have the block and no semicolon. The problem, though, is because those two declarations are buried inside of the movie class, you're going to get errors. Here, I'll run it, and let's just get errors. It's going to be a wall. Yes. So Baby Doll asked the question, is this where the double colons come into play? And the answer is yes. This is where the double colons. This is one of the handful of places where the double colons come into play. Okay. So once I've taken these definitions outside of the actual class block, C++ doesn't know where these came from anymore, and it doesn't know what this refers to anymore. So the way you reconnect the function definitions to the class that they're meant to go with is you go to the function names and you reattach the class name : That's the fancy name for that double colons is the scope resolution operator. So by scope resolution, it means how is C++ to what scope does C++ resolve the setName function? To the movie class scope. And then we do the same thing here. So you notice how it's getting to be a big mess really, really fast. Oh, that's supposed to be string right there. I didn't match the original get name. Okay, so let's look at these for a sec. So I have pulled the definition of the set name, the setter function, outside of the class, but I still have to tell C++ where it connects back to, the movie class. And notice it's on the function name, not on the return, not on the void. It's on the function name. Same thing on the getName getter function. I have to more or less reattach it to the movie class so that C++ knows where it came from. So now that is the movie class a little bit more separated out. So this is yet another way you can do this in C++. And now it runs again. Okay, so now let's make it harder and then harder once more so that you see the sort of correct way to do it. Okay, so typically if I were making this movie class and implementing its functions, I might imagine that this could be useful to me in more places than just this week's work. So what we will often do is we'll create a separate file to contain all of this code for the movie class. So I'm going to create a new file up here. And I'm going to call it movie.h. By the way, you might imagine that this is how doctest.h works, which it is. Okay, so I made a file, movie.h. And now I'm going to go into the original code. I'm going to grab the movie class and the functions that go with it. So the original movie class with the declarations inside, and also the two functions that I've implemented outside of the movie block. So I'm going to cut those, and I'm going to paste them into movie.h. So that's the same movie code, the two functions and the class, now in its own separate file called movie.h. Now we need to do some cleanup here, but that's the first step. So let's do a little bit of cleanup. The first thing I'm going to do is called this is kind of a compiler guard. I'm going to show you where this comes into play before I stop talking at you tonight. But when you make a .h file for a class that you're creating, get in the habit of putting pragma once at the top of it. Only in .h files, by the way. What this does, and I'll show you an example you'll see an example in this week's lab of where this is needed. What this does, though, is this ensures that the compiler only reads through this code once. And there are chances when you're separating out your components that the compiler is going to think it has to read it a second time, and if it does, you'll get errors. It would be just like declaring the same variable twice. So this guarantees that the compiler doesn't try to process this stuff more than once. The other thing that we do when we separate out the components is that we make sure that they have the includes that they need separately, just in case. So in the case of movie, it uses a string, and in C++ that requires an include. And it is a lot more convenient if we include the namespace directive as well. Alright, so there's movie moved into its own .h file, all of its code. I want to do Control S, but you don't do that in REPL, it just saves. I'd rather have the satisfaction of feeling the save, but whatever. Okay, so hopefully you kind of tracked along still. And what I'm doing is sort of building from the ground up to where you actually start the lab with all the stuff already separated. Okay, so let's go back to main. You might notice, by the way, that main actually no longer has any direct references to strings. That was something that the movie did, so I don't actually need that here anymore. I only need couts and endlines, so I don't actually need the string include. But now that movie's been separated out, I actually have to include movie. So when you are making your own code and your own classes, and you have them in your project or your REPL project, you don't use the greater than, less than brackets, you use quotes around it. So the brackets are built-in C++ libraries, and the quotes are more or less your own custom code. So that's how you include movie.h in your program, which causes C++ to go read what's in that file right at the moment it sees the include. That way when you start to refer to it, C++ knows what it is. And it should just run. Alright, so there's the same results. JAWS and Tenet. So we're almost there to the all separate parts. Okay, so that's sort of the magic of getting a separate component. Now there's one more trick, and that is, and you're going to see it in the lab, it's very, very common practice to take the definitions and separate those out as well. So I'm going to create another new file, and I'm going to call it movie.cpp. So movie.cpp, its job is to contain the definitions of functions that go with the movie class. The names in C++, the file names, don't actually mean anything, but it would be confusing if I called this donut.cpp and add movie code in it. So anybody who's not crazy is going to name their files connected to the thing that's inside of them. But technically I could call this anything I wanted to .cpp. But that would just be weird, so don't do that. Okay, so now movie has two files for it. So the .h file, we call that the header file. And by headers, what we really mean is declarations of stuff. So the fancy word for a function declaration is a function header, which is really just the heading, the first line of the function. So this is a header for the setName function. This is a header for the getName function. So .h files, you'll often see people separate out. So I'm going to cut the definitions. You often see .h files used for only the header parts. Just basically the class block and the declarations inside of it. And then in the CPP file, you see the definitions of that same stuff. Two separate files. Now it turns out that this will not work unless you include movie.h here, because C++ still has to go back and see where did all this stuff come from. So in the implementation file for movie, where you have the function definitions, you also do an include for movie.h, so that C++ knows to go look in there so it understands what this stuff means in here. That's pretty wild, isn't it? Notice with the quotes again. So now we have a fully sort of traditional, conventional way of separating out all the parts of one component, the headers into a .h file, the implementation in a .cpp file, and then an include that connects them both together. If I run the program, by the way, right now, it should just work. Alright, so it still works. That's reassuring to know. So until you get used to this, it seems needlessly complicated, and sometimes it is probably needlessly complicated. So someday you're going to be an engineer in the field, and someday you're going to be a team lead, and someday you're going to be a manager, and you may decide to break all of these sort of conventional practices in the interest of greater simplicity. But you're going to see code put together like this a lot in the world. Okay, so let's go back and look at what we have. If we go back to main, we'd call this the program's driver, because it has this function in it which sort of drives the rest of the program. This include allows the C++ compiler to go over and read movie.h and pull in the required declaration so it knows what's allowed and what isn't. So yes, there is a setName function. Yes, there is a getName function. That kind of stuff. Notice, by the way, there's one include for movie.h. So if we go to movie.h, all there is the headers, the declarations. And we would have to sort of be savvy enough to realize that, oh, I bet movie.cpp has the definition. So if I click on that, I'll realize, yep, that include for movie.h, which is include number 2, by the way, for movie.h, all the definitions are actually in here. Those two includes, by the way, would potentially cause a compiler error, because if you include the same thing twice, you're actually asking the compiler, so there's an include in main, Here's another include in movie.cpp. You're actually asking the compiler to read it twice, which would lead to errors, except you've already told the compiler, if you've been here before, don't come back. So immediately, hopefully, you sort of have some sense of why this once guard is in here, because if you have the same include more than once, and we do in this program, then you run the risk of getting compiler errors, because the compiler is going to say, wait a second, I've already seen all this stuff. So now you're telling the compiler, yeah, if you've seen this stuff, just move on. Okay, so that's fully set up as a sort of fully conventional object-oriented program in C++. I know I'm flicking around a lot. Hopefully that's not throwing anybody off too bad. There's 3 files here. There's the driver, and then there's the movie, which is separated into 2 source files. The header file, which has just the declarations, and the CPP file, the implementations of all the functions of movie. I'll give you a second to sit on that before I say one more thing, and then maybe look at constructors, and then the lab. Okay, so if it feels like it's complicated and stuff is all over the place, it's totally understandable. There will come a day where this just makes sense to you. This is the way that software is built, and you won't even think about it anymore. In fact, it'll look weird to you when people try to pile everything into one file. You'll think, why are they doing that? How are they supposed to reuse any of this code if they just pile all of it into one file? But until that day arrives for you, it is a little complicated. You sort of just have to stop and remind yourself or ask yourself what's going on here. In Replit, main.cpp is always the driver. It's the entry point for the program. It's what triggers the rest of the program's behaviors. And then if you look around, typically what should be true is that you'll see pairings of .h and .cpp files in our class. And then occasionally you'll see us pile, like doctest piles everything in the .h file. They did that so it's easier to move it around. Okay, so why do we do this? Why do we separate the implementation out from the headers? One of the practical reasons to do all this separating stuff out, for another programmer to use my movie class, technically all they need is the headers, the .h file. If another programmer has access to my .h file, they can see everything that they need to see about what this does. They can see what the functions are, they can see what the parameters are, they can see what the return values are, they can see what the data members are. So a programmer should know everything they need to know about my movie class just by looking at the .h file. So, and they should have really no reason to look at my .cpp file directly, because that's just the way that I wrote the code. So in the real world, one of the things you can do with this is you can sell libraries of code, and your libraries can have the fully readable header files so that other programmers know what's going on and know how to use it. And you can pre-compile your implementations and hide your super secret algorithms inside of it if that is your desire to do so. So it's, in the real world, an advantage of separating all the pieces out like this is that we can pre-compile the implementation files, and now the actual details of my implementation aren't visible to people. In other words, it protects my intellectual property, if you're into that kind of thing. So that's one practical use of separating things out like this. Okay, so that's, how am I doing on time? I'm doing okay on time. So we started everything in main, and then we pulled out the function definitions but stayed in main, and then we pulled all the movie code out into a .h file, and then we separated the movie stuff out into headers and implementation. So we still really just have the movie class, and a driver that creates two movies and changes their names and prints stuff out about them. So all this really is that we've done is organize the code differently. That's it. We've just organized the code differently. Some languages don't give you as many choices about how to organize the code as C++ does. C++ gives you a lot of different ways you can do it. So you've just seen how many? 1, 2, 3, 4 different ways of organizing the code for just the movie class. So now let's add at least one more piece. So I wanted to show you just working from the blank screen. So what if I want the movie to be different? What would we do? So if we want to change the movie, typically what I do is I start in the header file. And often the change is going to be an addition. And this addition is yet another new thing that we're kind of just piling in this one week's work. But I'm going to create a special kind of function here. Let me all caps that so you can hopefully maximize your chance of reading it. Okay, so this is like our last new thing. I know the organization part, that's fairly complex. But this is, I think it's the last brand new thing, is what we call a default constructor. So let me go change my driver. Let's comment this out. And go change the driver just to see where we're at. So after I do the movie here, I'm going to see out its name. Oh, dang. Hopefully it came back to where you see everything. I think it did. Okay, so, and I'll show you a couple tricks while I'm at it. So to build up to this next, and I think the last sort of big new thing, let's add a couple of couts in the driver that attempt to get movie 2's name this time. So before we change the movie's names, let's print out their names and see what they look like. So I did a m1.getName up here right after I created m1, and then an m2.getName right after I created m2. And I'll show you a trick while we're at it. So there's a couple of blank lines, which is probably the movie's names, and then Jaws and Tenet around it. So here's just a tip. If you have an output that you're not sure if anything's happening there, one trick that I like to use is to bracket it. So by placing these brackets in here, you can see what, if anything, is in between them, which in theory is the movie's name. I'm going to bracket this other one as well. So this is a trick. If you have an output and you're like, well, where is the output? I don't see anything, but you're positive you should be seeing an output. Try to put a bracket around it, or asterisks, or whatever you want. I usually just use brackets because I like the way they look. And then you can run the program and you can see, is there even anything there? Is there something in between? What's going on? Okay, so here's the brackets, and there's nothing in between. So when I first create the movie, its name is literally empty. We call that the empty string. That's what we call it in every programming language, the empty string. It's nothing. There's no characters, there's not even a space. And same for M2, it's nothing. So without me doing anything to change the name, to set the name is nothing. So let's go work on that and consider it a problem. So I'm going to go to movie.h. So my problem is, at the moment of creation, movies don't even have a placeholder name for their name. They just have nothing. So it's the moment of creation part that's important here. So constructors are special functions that allow you to set up objects at the moment of their creation. Now we're going to set up the default constructor because that's the one that we need right now. We would like movies at the moment of their creation at least to say title not set or something like that. So I'm in the .h file. I'm going to add a new function declaration. Notice, by the way, there's no return type. That's on purpose. If you put a return type in front of it, you no longer have a constructor. You just have a weird function. So these moment of creation functions, or constructors, they're a special function whose job it is to allow us to set the initial values of things when movies, in this case, are created. So here is my declaration in the .h file. Now I'm going to go to the .cpp file. I like to keep these things in the same order, by the way, so when I go to the CPP file, I'm actually going to implement this at the top. So right under the include here, I'm going to put this movie function, and I'm going to implement it. It has the same problem as all the other functions do. We have to remind C++ where this came from. And I'm going to say that the name of any movie at the moment of its creation is title not set. That's the end of the T. So this is the implementation of the default constructor. We'll come back to what default constructor means in just a second. Don't forget the colon, and do not put a return type. Constructors are special types of functions. They don't have return values. So at the moment of the creation of any movie, I just want to have its name say title not set. So I updated the CPP file for movie, I updated the .h file for movie. I did nothing different in the CPP file, nothing. It's the same as it was a second ago, but I'm going to rerun it, and it's going to recompile all that stuff. So now the titles at the moment of creation are not set for the movies. One thing, by the way, that you can't see here is how is movie.cpp being compiled. REPL's doing that for us. REPL knows that other CPP file is there, and it's compiling it in, bundling it together for us. Okay, so there's the default constructor. There's one thing. How many? I should have kept a list of how many things that I say this is a tough thing about C++. There's a lot of them. There's no evidence in here that default constructors are being used. Nowhere is there the word movie with empty parentheses behind it. Nowhere. So where is it? It's here. Unfortunately, this is just the way they decided to do it in C++. When you see an object being created with no parentheses anywhere, that's the default constructor being used. That's that special function being used to do something at the moment of creation. Same for movie M2. That's the default constructor being used. You'll just learn to recognize that. There's no parentheses around, but a movie's being created, so it has to be constructed, and that's the default. Okay, so another thing that you're going to see in the lab is it would be kind of weird to create a movie that doesn't have a name. So it would be nice if at the moment of creation I could just set the name, like all in one fell swoop. I create the movie and give it a name all in one fell swoop, as opposed to what I'm doing with M1 here, which is I create it, then I set it. M2, I create it, and then I set it. So let's go fix movie and give ourselves another moment of creation option, another constructor. So what we're doing is called overloading. This is overloaded, I'll call it overloaded constructor number 1. Yeah, so there's a question, is it good practice to have a default constructor or an error function? It's kind of a tricky question. So very often in C++, you're going to find that you need a default constructor because somewhere that you couldn't see it or you missed it, a default constructor was needed, and you get errors if it's not there. But we do occasionally create classes where we don't want people using a default constructor. Like you can't make one of these with the default constructor, and we take it away. So in our class, we almost always want a default constructor. We don't always need one, but most of the time it's probably good practice to have one, unless there's specifically a reason why you want to take it away. So once I've done an overloaded constructor, I can take the default constructor away if I choose to. Most of the time in this class, we won't do that. But there are occasions in the real world where you don't want people using the default constructor. You actually want to force them to give you data. So you'll overload the constructor and then take the default away. So let's overload it. And by overloading it, what we mean is we're going to add another constructor option, but we're going to change the parameter list. So we're actually going to allow someone at the moment of a movie's creation to supply the name. So I'm in the .h file. I created a declaration for an overloaded constructor. And then I'm going to go into the CPP file and implement it. I'd like to keep them in the same order. So I'm going to go below the default constructor implementation. So I know that's got to be there. So this constructor is actually sort of making the setter function be not as useful. But I've already written the code, so why not just leave it there in case I decide that I would like to have it later. And you know that how they do that with movies, they'll often have a slightly different title for the movie in different regions of the world. Okay, so here's my first overloaded constructor. The way C++ can tell them apart is the arguments. So the default has no arguments always, and this overloaded constructor requires one string. So now let's go look at the driver and see how do we use that thing. So I'm going to make myself a new movie. And with overloaded constructors, now you do use the parentheses. I still have Cars and Jumanji in there. So at the moment of its creation, I'll just set the name of M3, and now I can just go straight to, and I'll get the name Cars for M3. So that's what it looks like when you use an overloaded constructor. So there's Cars. Notice it didn't say title not set because I didn't use that constructor, I used an overloaded one. Okay, let's go do one more thing so that I can then go look at the lab before we run out of time. I'm kind of running out of time, but I want to finish the thought for you. So let's go back to movie, and I want to show you what you're seeing in the lab. So let's say I'm back in movie.h. Let's say that I want to add a genre to the movie. So technically, I would probably want to write setters and getters for the genre. I didn't put the comments in there, but that's not a bad habit to be in, and then sometimes you decide that you don't need them and you get rid of them. But if your fingers just want a variable setter getter, that's fine. I create a new data member, I create a setter and getter for that data member. It can come in handy to have that habit. So I'll go ahead and implement those just so you can see me do that. And then I'm going to leave the two constructors as it is and then go contend with my genre. So let's implement these things. Oh, by the way, here's the trick that I like to use. I usually just copy these from the .h file. So I'm in the .h file, I'm going to copy those two function declarations and then go to the CPP file and paste them in at the bottom, if I can get it to click. And then sort of do my little setup. So the first thing I do when I get them over here is I make sure that I reconnect them back to where they came from. That's easy to forget. So if you do it first, then you haven't forgotten. And then get rid of the semicolon and open up the block. Get rid of the semicolon and open up the block. This setter is for genre, so this movie's genre is the parameter genre. And then return this movie's genre. So there's the setter and getter for genre. Now, since I have a new data member, I should go make sure that both constructors deal with genre. So I will do this genre equals genre not set. And then on this overloaded constructor, I only have a name. So I still kind of have to go with the genre not set again because I don't have a value for genre with that constructor. So my program will still run. Of course, I'm not doing any sort of printing out of genres yet, but clicking run is a good idea. So hopefully that's not getting to be too much just yet. But again, the video will be available, and if you need to, you can stop and review. So let's do one more thing before I take a quick look at the lab and make sure that I've given you enough to be successful at it. So the default constructor, that just says title not set, genre not set. I have it overloaded constructor number 1, hint hint, where I can set the name. Now one thing you cannot do this. You cannot overload a constructor with the same type and number of parameters. So C++, when it's doing error checking here, it doesn't care what label you used. It just cares what type of things are in the parentheses and how many of them are there. So 2 movie constructors with 1 string each is not allowed. So that you cannot do. So is there another option? Because it would be nice to have a moment of creation where we set both the title and the genre at the moment of creation. I'll do a little hint here and see if anyone can work with this. So we do want a second overloaded constructor, but what should it do? We can't redo the default because there already is one. We can't do an overloaded constructor with just 1 string in it. That wouldn't be allowed. But there is an option here for us overloading again that lets us deal with all of our data. There you go. Nice one. Yeah, good one. So Damien and Baby Doll. A 2-parameter overloaded constructor where I supply both. So now there are 3 functions that provide 3 different options for creating movies somewhere in an application. Let's go implement this. I'm going to copy it, which is usually the best way to make sure that when you go implement it, so it's the 3rd one down, it matches. So block, and then make sure you get the movie colon on there. Yeah, so that's right. We need to overload it, or at least it's nice to overload it one more time, because we can imagine that people might, when they're creating movie objects in their application, might have the title and the genre. The other thing is just to sort of let you in on the idea that in theory there's no limit to the number of overloaded constructors, as long as the number of parameters and the types and the order that they're in are always different. Then you can do more overloads. And you'll see libraries that have lots of different constructor options. So now we can load up everything right at the moment of creation. So now we have a second overloaded constructor, in addition to the first overloaded constructor, which was just the name of the movie only, and then I should have called it title, and then the default constructor, which just makes them both say not set. Okay, so one last test here is to go use it. So let's go to main, and we will create one for Frozen. I feel like the genre is Disney. So here I'm using the second overloaded constructor option to create the movie M4, and then I could want to, if I want to, say M4.get name, maybe a comma, and then M4.get genre for Frozen. Yeah. Who doesn't love Disney? They bring joy to life for real, right? Although if you look at old Disney movies, some of them are kind of dark. Like Snow White's kind of dark. All right, so there's my Frozen Disney using that last constructor option. So that's a lot. I know that's a lot to take in, since we're sort of compressing our lecture into one night. Hopefully, if you are using the videos, you find those useful. Oh, I haven't done. Oh, that's interesting. I haven't seen Mulan yet, the newer one. Okay, so I'm going to go look at Lab 5 real quick, just to see if there's anything that jumps out at me about it. So the Lab 5 code itself, you don't have to do anything. It's the unit test, and you'll notice this time there's actually 3 different sections which you can do. So I just want to call your attention to this because now we're fresh on it. This first section is testing the default bank account constructor, no parentheses, see. The second section is testing an overloaded bank account constructor that takes an account number only. And then the third section is testing a second overloaded constructor that takes an initial balance and an account number. Hopefully those are in the right order. So that's why there's 3 test cases, because they're testing the 3 different constructors that you will implement in bank account. Bankaccount.h. So you don't have to touch this. You do need to copy stuff out of it to get started, but this is all declarations. So the public members of bank account are default constructor. There are some notes here about what the default value should be. One overloaded constructor that takes an account number, and then a second overloaded constructor that takes a balance, a starting balance, and an account number. Then there is a deposit. This is like increased quantity. You increase the balance by an amount. There's a withdrawal, which is very much like reduced quantity, where you reduce the balance by an amount. And as long as that amount of money is available. Here's a getter for the balance. Here's a getter for the account number. So notice we didn't write setters in this case for the balance or the account number, and that's common. And then it's a string, which is something that we practiced in last week's lab. Very similar. You need the magic formula again. There's a sample of how it's supposed to be formatted. No new line, I suspect. I don't think you put a new line on it. So that's the bank account .h file. That's the headers. And then if you go to the CPP file, I actually already brought these over and left them blank for you. I won't always do that. So there's the include of the header file. I've done the colon bits everywhere for you. And then I've set up the empty blocks waiting for code to go inside. So that's the task. Hopefully you are armed to do well on Lab 5. Please look at the individual project one especially, and get on Piazza if you have questions, and let us all kind of work together to get you past whatever obstacles you find, or to help you work out your ideas, whatever it is that you need. I appreciate it, Damon. Thank you. Damien. Maybe all thanks, Little Peeper thanks. Tyler, everybody else who's here that I can see at least. Bad Hawk, Dice Case here, Glazer, Javier, Fikur. Thanks all of you for being here. If I can't see your name, thanks to you for being here. Thank you. Yes, everybody have a good night. Have a great week. I think I hope it goes well for you. Please get on Piazza and let us have a chance to work together and solve problems, which is one of the more fun things about, it actually is the fun thing about programming, is solving problems. And they don't have to be our own problems for them to be satisfying to solve. So don't forget that. So have a great week. Thanks for being here. And if you're watching later, hope you have a great week too. Otherwise, I'm out. So take care, everybody, and see you on Tuesday next week.